In the previous section, we took a look at how we're going to go through and verify some of these sorts of argument forms by utilizing the universal modus ponens and universal modus tollens. However, in this video, we're going to take a look at how we can go through and do the exact same thing, except utilizing Venn diagrams. And so let's take a look at 4 examples as to where we can utilize the Venn diagrams to do the exact same thing that we did previously. And of course, if you want to use the previous methods, you're certainly welcome to, just to verify. So the first one we have is that we have the argument that all teachers make mistakes, gods never make mistakes, teachers are not gods. And so we want to determine not if necessarily the statement is true, but whether the argument form is true. And so every time that we try to do one of these types of argument forms and try to verify them, we're going to go through and do this utilizing a Venn diagram by using two parts. We're going to have a major premise and we're going to have a minor premise. And the major premise, which we're going to look at first, is going to be the larger or the overarching group, if you would. So in this case, we have all teachers and we have make mistakes. Okay, so we have people that we either have teachers or we have people that make mistakes. And since all teachers make mistakes, people that make mistakes seem to fit into the major premise. All right, so when we're drawing our Venn diagram, the first thing we're going to do is we're going to draw a very large circle and we're going to have people that make mistakes. And I'm just going to say make mistakes. And inside of that Venn diagram, I'm going to have all teachers because all teachers fit inside. So this is make mistakes is your major premise and teachers are your minor premise. So this is, I'm just going to abbreviate MP, or let's say MAP for major premise. And right here is your minor premise. I'm going to call that MIP. Now, it says gods never make mistakes. So gods are on the outside of those that make mistakes. So right here, I'm just going to draw a dot and we'll have gods. We'll make it lowercase as to not offend anybody. And on the outside, we have gods that are never making mistakes. So hence, teachers are not gods. And clearly that's valid because since teachers are the minor premise and people that make mistakes are the major premise and gods is outside, we can clearly see that this is valid. So what we would say is that this is valid by the diagram. Let's see if we can get that down. All right, so this is valid by our diagram. So whenever you're drawing these, suggestion would be to draw the major premise, then the minor premise, and then the specific instance. All right, a second example. All polynomial functions are continuous. 1 over x is not continuous. 1 over x is not a polynomial function. So the major premise would be that there are functions that are continuous. So let's draw a major premise, and we're going to say, let's say functions that are continuous. All right. And all polynomial functions are within that. So let's go ahead and draw a circle here. And this is, as best as I can fit it in, polynomials. Now, 1 over x is not continuous. All right. So on the outside, so all polynomial functions are continuous. 1 over x is not continuous. So we have this outside of here, and we're going to call it 1 over x. Therefore, 1 over x is not a polynomial function. And once again, it seems like we have a valid Venn diagram for this. So we just have to be careful as to what we define as the major premise and the minor premise. Okay, so once again, we're going to say valid by our diagram. All right, now, all students eventually study. Chris will eventually study. Chris is a student. Okay, so major premise. Since all students eventually study, people that eventually study, so let's just call this the eventually study, which is the major premise. And inside of here, we're going to have our students. All right. Now it says Chris will eventually study. So now that doesn't necessarily mean that Chris is inside. So inside of study. So for example, it's certainly valid that Chris could be here, but wouldn't it also be true that if we had our eventually study and we had our students, couldn't it also be true that Chris could be inside of the people that eventually study, or all students, excuse me. And so now we have like this dilemma in which we have two different diagrams that seem to pose the exact same argument. But which one do we pick? Well, they're both true. But in one of them, Chris is a student and one of them is not a student. And so which one do we pick? Well, they're both valid. And so we can't necessarily pick one. And what we're going to say is that it is invalid because there are due to, or due, not to, but to, excuse me. So due to two valid diagrams. Okay. Now, what you could do is you could use the method that we used before with the predicates, and eventually what you would see is that this is a converse error. All right, so I urge you to try to utilize that method to verify. Right. One last example. So no gentleman smashed phones with a bat. David Ortiz is not a gentleman, therefore David Ortiz smashes phones with a bat. And down here you can see David Ortiz is smashing a phone with a bat. So is this valid? Well, we don't know, but is it a valid argument form? Let's figure that out. So we have our major premise, which is people that smash phones with a bat. I don't know too many of those. I do know David Ortiz is one of those people. So we have our smash phone with a bat. All right. Photographic evidence right here that he does. And then we have gentlemen on the outside, and clearly gentlemen are not part of that group. So maybe what we could do is we could just put right here, let's say gentlemen. And it says that David Ortiz is not a gentleman. All right, so it's very true that David Ortiz could be right here. So I'll say DO for David Ortiz. But could it also be feasible that we have this group? So we have smash phone with a bat. And then over here we have our gentleman, which I'm just going to abbreviate G. But couldn't it also be true that David Ortiz could be in here? In fact, we could just see from the picture that he could be right there. All right, not saying that he is, although the picture does say that. And so once again, similar to the previous instance, we have two possible and also two valid instances that kind of contradict one another. All right, so what we can say is that this is invalid due to two valid diagrams. All right, so it is possible that David Ortiz smashes phones with a bat, and he is a gentleman. But it also might be true that he neither smashes phones with a bat nor is a gentleman. So it's just up to us for interpretation. Once again, if we were to go through and to utilize um, the method that we saw before by turning these into statements, then it might be a little bit easier for us to see that this is an invalid argument because it doesn't follow the universal modus ponens, nor does it follow the universal modus tollens. All right, so hopefully this helps you to understand how to utilize the two different methods, one with Venn diagrams and then one with the syntactical argument forms, to be able to determine if one of these sorts of instances with the argument forms is valid or if it's invalid.